So I'm going to show you how our logical model works as it now stands. I'm going to use an entity relationship diagram, or an ERD, and I'm going to illustrate it with an example in QGIS, desktop GIS system. So I'll just share my screen. Okay, so this is the ERD of the logical model, and I want to focus on 4 core tables, and those are the vineyard, the block, the vine row, and the vine tables. I'm just going to run through each one and show examples of them in QGIS. So the first one is the vineyard, and you'll see this has a few standard attributes. So it's got a name, an owned by, a street address, and a geom. And so these are just standard fields that we figure that most users will have some need for. And we can take a look at that in QGIS. So this is what the object looks like. This is a record in the database. And if we take a look at the details of this record, we can see, just like we saw in that diagram, it's got a name, it's got owned by, it's got a street address, and then the geometry is this shape of the vineyard. And that's something that can be drawn using lot boundaries or whatever makes sense for your use case. But the idea being that it's an envelope that contains all the objects of the vineyard. So the next table to look at is the block. And if we click on the relationship between the block and the vineyard, we'll see that the block has a standard attribute called vineyard ID, and that relates it back to the vineyard record. So a block is basically related to a vineyard through that identifier. The next standard attribute is the user-defined ID. And what this is, we've got a unique identifier for the database that the database uses, but the user-defined ID is actually if a grower has their own naming convention for how they name their blocks, this is where they would put that in. We capture information about the block, including row spacing in meters, vine spacing in meters. And then we've got the date start, which is the date that the block was established, and date end, which is the date that the block ceased to exist. Now, if a block is still in operation, then it obviously hasn't ceased to exist, so the date end would be blank or null. And then finally, the geometry, which is a polygon geometry, and we'll take a look at an example in QGIS. So turn on the blocks layer or table, and we can see there are about 20 blocks within this vineyard. And if we take a closer look at one of them, we can see how those attributes work. So we've got the vineyard ID, which is 1, which relates back to this vineyard record in the database. We've got the user-defined ID. So this is what the grower calls this block using their own naming convention. 3 meter spacing between rows, 1.5 meter spacing between vines along the rows. And then it was established on the 12th of July, 1998, and still in operation. So it hasn't ceased to exist. Therefore, there's no date end. The next core table to look at is the vine row table. And if we click on the relationship between the vine row and the block, we can see they're related through this use of a block ID. So a vine row is related to exactly 1 block. We've got a user-defined ID similar to in the block. So if a grower has their own way of referring to their vine rows, they can put that in here. And we've got orientation, which is the directional orientation of the vine on the ground, or the bearing in degrees. And finally, geometry, which we see as a line string. So if we look at this in QGIS, we can see what these line strings look like. And we can choose vine row to look at its attributes. So there's that line is the geometry in the database. And the block ID is 18, so that relates to this block. So we can see. The user-defined ID for the vine row. So the grower's identifier for that vine row is 38. And so if we look in this example, the grower is using a sequential numbering system for the number of vines, the number of vine rows within that block. So that's vine row 38 for this particular block. Different growers might have different systems. And the orientation is 119 degrees from due north. And so the last core table to look at is the vine table. Again, we can see that it's related to a vine record is related to exactly one vine row record. So a vine belongs to a vine row, makes sense. We use the user-defined ID again. We've got a variety ID, which this is a way to put the variety, like the type of grape, into the vine record. And we'll see it's using an ID method, which relates to this variety table over here, which we'll talk about in a minute. You can put in the clone, you can put in the rootstock, and a point geometry for that vine. So looking at this in QGIS, let's turn on the vines. So our example vineyard has 40,000 vines across the vineyard. And we can go into any one of them and see, we can label it with its user-defined ID in QGIS, and we'll just take a look at the attributes for one of these vines. So yeah, they're labeled in QGIS with the user-defined ID. The variety ID is 4, which in this case is Chardonnay, and we can see that in the variety table when we take a look in a minute. And the clone is 1, 2, 3, 4, and the rootstock is own. Okay. So we can see how all the records in the database are related to each other through this model. Okay, so another thing I wanted to talk about here was these attribute tables off to the sides. So the idea here is we want the data model to be flexible enough that it can be used in different types of situations by different people. And so these core tables only have a few universally applicable standard attributes. So the name, owned by, and street address, we figure are usable by most people across the board. But different growers might have different requirements for capturing different information about their records. So rather than expand the list of standard attributes to try to capture everybody's situation, we've used this concept of an attribute table, which allows the user to define virtual fields. And I'm going to show you what I mean by that here. So if we take a look at the existing attribute vineyard attribute table, I've already populated it with a few attributes, virtual fields that I'm interested in as a grower, let's say. And so I want to put in my grower code. I want to put in the winery that it's related, that my operation is related to, and I want to put in the geographical indication region. If you're using this, you might have a couple of other ones you want to add. So you say you want to add the ownership type and who it's operated by. You can just insert those records into that table. So let's refresh the table. So we've just inserted those two records into the table without actually having to change the underlying data model, which means that the user can extend this model without having to actually change the model. So we can all be using the same model. So just to take it one step further, I'm going to transpose this table into a format where it can actually be joined against the vineyard objects. So rather than it being a list of attributes, it's actually been transposed into a single record with a number of columns. And now this is kind of like a little bit esoteric and might only be of interest to database people, but I just want to demonstrate that. But really, the bottom line is that, well, there are only a few standard main attributes in the core model. You can actually extend the model, you can actually extend the database to suit your needs without having to change the underlying model, which means all different users can use the exact same model. Okay, so the last thing I want to talk about with regard to this model is this variety table. And so this is like a lookup table of varieties. And so the benefit of this, well, actually, let's look at the list of varieties here. So if I open that, if I run a query on the variety table, we can see, so we've got 38 records, and they've actually got the names of the different varieties in question. So the benefit of, well, there are a number of benefits of this. I actually won't get into too much detail, but in this case, what we're doing is we're pulling in the data from a third-party source, and I will just bring that up. So we've Collaborate Culture has taken the grapevine varieties from Wine Australia and actually put them into a GitHub repo. And the idea here is that if we have like a shared list of varieties, then we're not, then we can make sure that we're all using the same spellings, the same namings, and we can make sure there's consistency between different databases. And so if we look at this, so this is listed in code, which actually makes it quite easy to pull into a database, which we've done. So we've basically just pulled in this coded list of varieties and using our database. So anyway, this is potentially another shared resource that can make the database that much more interoperable. Okay, and the very last thing I want to show you is how we can start to use the power of the relationships between these objects by using database queries. And for people who've been using relational databases for a long time, this isn't news, but I just wanted to demonstrate this in the context of our sample data. So by running this query here, this is pulling together data from the vine row table and the block table and running some summary statistics on it. And so we can see that for all of our blocks, we've got a count of the number of vine rows and the total length of meters of those vine rows for that block. So immediately you can see the state of play for your vine rows over the blocks. Similarly, we've got another query here. That's the summary statistics of the vines by the block. And so we can see for each block, again, what variety of grape it is, the clone and the rootstock we're using, and the number of vines within that block. And the last query I'd like to show you here, this is where it is getting a little bit more complex. This is a view of the blocks. This is a query of the blocks with those attribute tables joined in, with some of the vine row stats joined in, and with doing some calculation of the area of the block geometry on the fly. And I'll just run that here. As you can see, we've got all this data kind of pulled into one single view. And because it's got the geometry here, we can also take a look at it in QGIS. So I'll just open that up in QGIS. And we can see, we turn on that view. So this relates to that particular query that we just ran. And we can see that all those summary stats it's calculating on the fly can be, you can use them to you can use them for analysis or visualization, whatever. In this case, we're using it to show the statistics for each of the blocks in QGIS. So just labeled it with all the attributes from that query. And I think that's about all I've got to show you here. So yeah, we would love to get your feedback and hear what you think, and any suggestions you have for improving it would be very welcome. So thank you very much.